Okay. Let's see. We've got a shorter class today. Well, I guess. But tomorrow we're taking a test. So let's make sure that you know. Let's make sure that you know what you're doing here. There are new problems and old problems. Let's go over both. I think almost all of you got the new problems done yesterday. Did all of you get the old problems done? Some of you did, some of you didn't. Let's just go through these and have your piece of paper out so you can see what we're doing here. Yes, we're gonna go over both of them. We'll have just enough time, I think, to go over both of them. All right, number 1 and number 2. When we were working on this yesterday, a whole bunch of hands went up immediately for me and Mr. Vickers to come around and help you guys with problems 1 and 2. Because problems 1 and 2 are really tough. As long as you do have to remember how to do simple radical form. Hold the question for just a little bit there, Henry. Let's figure these out. Step 1, multiply them together. What's 6 times 2? Here's the hard part. What's x times x? Don't say x. It's x squared, right? A lot of you yesterday when I was helping you with this, I would be helping you with this problem and I'd say, what's x times x? And you would say x. It's not, it's x squared, right? Just like 2 times 2 isn't 2, it's really 2 times 2 is 2 squared. So this is x squared. Now that you've got it like this, now you want to think about those numbers that were on the board yesterday, like 1 and 4 and 9 and 16 and 25 and 36 and so on. Those are the what kind of numbers? Perfect squares. Excellent. And what you want to do when you're simplifying this is find the largest perfect square that goes in. What if you can't remember those numbers tomorrow? Do you raise your hand and ask me what's the perfect squares? No, because it's a test. I'm just going to say it's a test. I can't tell you that. You can recreate them very quickly and easily. Just type in 1 squared, 2 squared, 3 squared, and so on and so on, 4 squared. You can figure out all those numbers yourself just by typing them into your calculator. Okay. Now, you just said 4 goes into that, right? How many times? 3. 4 times 3 is 12. I'm not going to change x squared at all because is x squared a perfect square? Yes, it is. So don't change something that's already perfect, right? If it's perfect, leave it alone. The things that are perfect get to come out. The things that are not perfect have to stay in. When the 4 comes out, what does it become? Because the square root of 4 is 2. And what is the square root of x squared? It's x. Again, that's the hard part that a lot of you had trouble with. The square root of x squared is just x because x times x is x squared. The thing that's not perfect, the 3, that stays on the inside. And so in simple radical form, you get 2x times the square root of 3.
Can I ask my question?
Yes, what's your question?
Why were these also on the old problems?
Because we also did them on old problems. Let's do this next one on the new problem. Notice that this 2 is already on the outside. Do we need to simplify things that are already on the outside? No, just write it down. Then 8 times 2. 16. What's x squared times x?
X cubed.
X cubed or x to the 3rd. But why am I not going to write it as x to the 3rd?
Because that's not a perfect square.
Yeah, I want to get things that are perfect squares. Is there already something that's a perfect square just waiting for me here?
Yes.
There is. So you could combine them together and get x to the 3rd, but I think you'll find it easier if you leave them separate because that one's perfect and that one's not, right? So leave it. 16 is perfect, x squared is perfect. So let's see if we can do 2 things at once. I think you guys can handle this because you're really smart. The square root of 16 is not 8, it's what?
4.
It's 4. And when I multiply that 4 by the 2 that's already out there, that gives me the 8. Good. And that x squared, what's the square root of x squared again? X. And that x is not perfect, so it stays inside. And we're done. I have a feeling problems 3, 4, 5, 6, 7, and 8 were pretty easy for you. But problems 1 and 2, some of you struggled with at the beginning. So if I was going to study something between now and tomorrow, I would study problems 1 and 2. Let's talk about the easy problems. Number 3, if something's 25% off, what percent are you still paying? 75%. Good. You're paying 75% because 100% minus the 25% off is 75. So I'm just going to type in 89.72 times 0.75. By the way, usually in this class, I spend a lot of time saying, make sure you write down your work. Everything's got to be on paper. Can you do these problems totally on the calculator? You really can. And that's why these are kind of nice. So I just multiply this times this, and I get $67.29. How do we do on that one? Pretty good. Question, Henry.
Are there any badly worded ones on the test?
Badly worded? If I wrote them, they're probably all badly worded because I'm not so great at English.
It's not which one is not about.
Me no talk good.
It's not about being off.
What?
It's not a price.
Oh,
That's the
is this
word.
clear? Does this say, this says, what is the sale price? Is that clear what I'm asking for?
Yes.
I think it is, right? I want to know, what is the sale price?
But what about the 20% off sale? We're talking about that.
This is a 25% off sale.
Yeah, but
Now, what if I would have changed this for my English, which is not so great? What if I would have said, how much off are you getting on the shoes? Would that have changed things?
Yes.
Yeah, then I would have taken $89.72 times 0.25, and you'd have said, you're getting $22.43 off. But the way this is worded, it's not asking how much was taken off. It says, what is the sale price? So the sale price is $67.29. But Henry brings up a really good point, because you do have to be careful how these are worded, because sometimes I want to know the total. Sometimes I only want to know the partial. How about this one? Sales tax is this. How much does this item cost after tax? Am I asking for the total or just the tax? The total. So do I add or subtract to 100%? Add. Good. So on your calculator, you're going to type in 72 times 1.0875. What do you think the biggest thing people get wrong on this one? What do you think they typed in instead of 1.0875? 1.875. They forget the zero, right? You got to move that decimal point 2 places, not just 1 place. But you get $78.30. How we doing? Still good? Everybody still happy? Yay, happy. All right, no, number 5. You go to a restaurant, the bill comes to $34. How much do you leave for a tip? Am I asking for the total? No. So this is like what Henry was talking about. We don't want the total this time. I'm not multiplying by 1.18. I'm just multiplying by 0.18. So 34 times 0.18. I'm only asking for how much we're leaving as a tip, and it is $6.12. So even though this is math clash, again, I'm not so good with words. You gotta read them words to make sense of the problem. All right. Popular new article has 44,000 views on Twitter or whatever. And the number is rising 40% per hour. How many views will the article have after 4 hours? Okay, total or not total? Total. So up or down? Up. So what am I multiplying my 44,000 by?
1.4
Excellent, 1.4.
to raise to the 4th power.
Raised to the 4th power. Where are you getting that from?
34 hours.
Ah, so you're telling me that you're using a totally different equation now. We just switched gears, didn't we? We are no longer doing basic percent increase or percent decrease. Now we're doing exponential growth and decay. And this is an example of exponential growth. So you guys correctly figured out that you're taking the A, original amount, times B, the common ratio, and you're raising it to the 4th power. And you got 169,030. Because it says round to the nearest whole number. So you did that. Still happy? Good. Number 7, we have bacteria growing at a rate of 10% per hour. So I'm going to type in 50,000. And it's growing. So what do I type in? Times what? Excellent. 1.10 or 1.1. And we're raising that to the, good, raise that to the 14th power, and we're rounding off to the nearest bacteria, which is 1,898,7,5. Good, because the 9 says we're going to round that up. Again, these are, I think, going to be easy for you. Yuckville. You can see why people are leaving.
Yeah.
It's not a very nice place. Yuckville, population 22,000, is losing 4% every year. Now, could you multiply by 0.04 and then subtract that from the 22,000? But that's not how you did it, did you? Yeah, you figured it out the easy way. You typed in 22,000 and multiplied by what? 0.96, because if it's losing 4%, isn't it keeping 96% of its population each year? So times 0.96, and we're raising that to how many years? 7 years, and we're rounding off to the nearest Yuckvillian, which is 16,532 Yuckvillians, or Yuckvillites. What do you think it would be? Yuckvillites? Yuckvillites. That sounds more, yeah, that sounds way better. All right, any questions on those? Let's talk about old problems. Same formula we were just using. Y equals A times B to the X. B is the common ratio. A is how much you started with. What's another way of saying how much you started with? The y-intercept, because the y-intercept is where X is 0, and when X is 0, that's like a starting point. So Y equals, what's our starting point? What is Y when X is 0? 3. And what are we multiplying by? How did you figure that out? What if you're not good at math and you don't know that it's 6? How could you use your calculator to help you figure out that each of those is a 6?
108 divided by 18.
Okay, 108 divided by 18, 6. What's 18 divided by 3? What's 3 divided by 1/2? Oops. 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 What's 3 divided by 1/2? It's 1.5. What does that mean? That means, yeah, that means we put it in wrong. What did I do wrong when I typed this in?
Oh, it's 3 divided by 1 divided by 1.
Okay, it's 3 divided by 1/2. How do I make the calculator think of 1/2 as one number instead of
Whatever you divide by
parentheses?
a fraction, you flip the numerator to denominator.
Yeah, so, and that's a good thing. Yeah, if we want to do a little 6th grade math on this, if you divide by a fraction, you're multiplying by the reciprocal. So you could either just put it in parentheses, or you could take 3 divided by 2 over 1. No, times 2 over 1. 3 times 2 over 1, like your 6th grade teacher taught you, and you get 6 either way. Anyway, the answer is y equals 3 times 6 to the x power. And that's all you got to do for that one, right? Again, all I'm asking for is the equation here. I don't want you to do any calculating with it. I just want you to get the equation. All right. You could either way. Yeah, what if you decided to put f of x here instead? That's totally okay. Either way. All right, to do problems 2, 3, 4, and 5. Let's see, here's what you need to know. You need to know that x to the m divided by n is equal to the nth root of x to the m power. Remember how I said if I was taking the test tomorrow, I would maybe study how to do these 2 problems, since those are the only 2 that any of you really struggled with yesterday. I would also maybe study this. Make sure you know this, because this is, remember we talked, this is kind of like your Spanish to English dictionary. You need to know how to go from here to here and from here to here. Because if you know this, then all these problems are super easy. Because does this problem look like the right or left side of this? The right, because it has a radical. So I want to turn this into this. I want it to be a rational exponent. Rational is just a fancy way of saying fraction. So this is 13 to the what power? 1/3. I don't see a 1. Where's the 1?
It's understood to be there.
Yeah, it's understood to be right there, isn't it? Yeah, so there's a little invisible 1 there. So this is 13 to the 1/3. Now, this one's the opposite. This time they give you the fractional exponent and they want you to write a radical. So write a radical.
4 on the outside, on top of the.
Yeah, that's called the index. So put the 4 in there where the index is, because that's the denominator, right? And this is going to be 7 to the, and there you go. Not scary at all, right? Hopefully. Number 4, rewrite in radical form. All right, same kind of a deal. We're going to put a radical there. What goes in the index? 3. What goes down here? 8 to the 4th. Is that the answer?
No.
Almost. But it says these mean words right here. Simplify if possible. Might it be possible?
Yes, very.
Should we ask our calculator for help?
No, because we had this question before and I remember.
And you remembered it. Let's say if you didn't remember it, let's ask the calculator.
It's
Hit them. It's how much?
The answer is 16.
16. So on your calculator, hit the math button. Try this right now. Math button is right there. Hit that math button. Do you see anything there that's going to help us find a cube
Go
root?
down to the 4 one.
Aha, that 4th one. And then we're going to type in 8 raised to the 4th power. So see how this looks identical? This looks identical to this. We're going to let our calculator help us to see if that simplifies. Henry was right. What's simpler, the cubed root of 8 to the 4th or 16?
16.
So next year, when you turn 16, you know how adults like to talk down to you and they kind of go like, they always like bow at the waist a little before they talk to you and say, how old are you? Remember that? And they do that. How old are you? And then you say, I'm the cubed root of 8 to the 4th. That's what you say next year. Okay. So when they say, how old are you? You say, I'm the cubed root of 8 to the 4th. And then you just walk away, drop the mic, walk away. That's it. And now you just showed them you are way smarter than they are. And they're like, oh my goodness, I need to go back to school. So remember that next year when you turn 16, I'm the cubed root of 8 to the 4th. Okay. Rewrite using a rational exponent. Well, now we're going the other way. This is 5 to the what power? Ooh, 5. What am I doing with a 5 there? Okay, I was confusing. I was wondering why you were all looking at me funny. This is 3 to the what power? Is it 2 over 5 or 5 over 2? It's 2 over 5. Now, here are these yucky words again. Simplify if possible. 3 raised to the 2/5. I'm going to say no. So there's your answer. It says simplify if possible. It wasn't possible, so we just left it like that. Okay. Next old problem. Simple radical form. Have we done some like this already? We did. We did some like this already. You have to remember those perfect squares. What's the largest perfect square that goes into 24? 4? That's it. 4 times 6. Yeah, 4 is perfect. 6 is not perfect. So when the 4 comes out, it becomes a what? A 2. The 6 is imperfect, so it has to stay inside. Remember doing that? Very similar to what we did on the first 2 problems. The difference was in the first 2 problems, there were X's in there. X's make everything more fun, right? Number 7. The 3 is already on the outside. Should I simplify it? No, it's already on the outside. Just leave it. But the 48, that could use some simplifying. What's the largest perfect square that goes into 48? 16. How many times? What if you're not good enough in math to know that off the top of your head? Yes, use your calculator. Just type in 48 divided by 16 and it will say 3. And that is a good indication that it goes in evenly. Did some of you start this problem by taking out a 4 instead? Because doesn't 4 go into 48? It does. Will you get the right answer?
Yes.
You will. It's just it's going to take you longer because you're going to end up with 48 divided by 4 is 12. And it does work. But is there a perfect square that goes into 12?
Yes.
4. Again, you'll have to do it twice, in other words. But we're taking out the largest perfect square, so we only have to do this once. But let's use our king size brains and limit the amount of actual work we have to do by doing two things at once. You ready for this? When the 16 comes out, what's it going to look like? 4. Now that 4 is going to be right next to this 3. So what are we going to do with 3 and 4? So what is 3 times 4? So do a little less work and just write 12. The 3 stays in there. Does everybody see how I got from here to here? I kind of did two things in my head. I took the square root of 16 as 4 and just multiplied it by the 3 to get the 12. Awesome. All right. Number 8. Ooh, they're putting radical or square roots in there, or variables. Eesh. All right, let's deal with the numbers. Numbers are fun. Letters are more fun. What's the biggest perfect square that goes into 75? 25. How many times? 3 times. So far, so good. Is x to the 5th a perfect square?
No, we can break it
No.
down.
What is the largest perfect square that goes into x to the 5th? X to the 4th. But if you take an x to the 4th out of x to the 5th, how many x's are still there? You need one more. Underline the things that are perfect. To me, this is sometimes confusing for people. Why in the world did you go to x to the 4th? You want to have an even exponent, because what's the invisible number that I'm pointing at right there? 2. And you know that 4 divided by 2 comes out nice and even, right? 5 divided by 2 doesn't come out nice and even. So you basically always, when you have an odd exponent on a variable, you just drop it down by 1 and have 1 left over. It happens like that every time. All right. When these two things come out, what do they look like? That's 5. And what's the square root of that? X to the 2nd. Yes, x to the 2nd. Because x to the 2nd times x to the 2nd is x to the 4th. And the two things that are not perfect stay on the inside. Number 9. Easy or not easy? Why is this one so easy?
It's already even.
It's all is 6. There's that invisible 2, right? Is 6 divisible by 2? Yeah, 6 divided by 2 is 3.
Third power and then extra third. Would there be extra third power under a radical?
No, because what happens when you take the x to the 6th out? What times itself is x to the 6th? X to the 3rd. So you have x to the 3rd times x to the 3rd is x to the 6th. So it's kind of like saying, what's the square root of x squared? It's just x. That's it. Same kind of a thing. Whew. All right. Ready for absolute value? All right. How many solutions?
So
How were we able to figure that out so quickly and easily?
Positive, nothing to have that value.
Aha, that's a positive. And is the absolute value totally isolated? It is. And so you know that there can be two numbers that have an absolute value that's positive, because it could be the positive or the negative. Now, before you tell me how many solutions there are in number 11, tell me why I have to do a small amount of work first.
Subtract 11.
You have to isolate the.
Isolate, yeah. So subtract 11, that will isolate the absolute value. So I want to get this absolute value by itself. This plus 11 isn't doing that, right? So I need to subtract 11 from this side and subtract 11 from this side. That will give me x plus 7, absolute value of x plus 7 equals 0. Now I can figure out an answer. They don't want me to tell them the solutions or solution. They just want to know how many. How many? 1. Can you have an absolute value equal to 0? Yes. The absolute value of 0 is 0. But there's only one answer. It's not 0 and negative 0. It's just 0. And that's why you get one solution. What if this said absolute value of x plus 7 equals negative 5? Then there would have been 0 solutions, right? Okay. Now they want us to actually solve. So here we go. This is fun. We're going to set up two equations, x plus 3.
One, the x is x equals 2.
So first we're going to set up this equation. Everybody gets this part of the problem right, because it says x plus 3 equals 5, and then they write x plus 3 equals 5. The part that sometimes people miss is they forget to do this. X plus 3 equals what? Negative 5. If you write that out, you're going to get the right answer. Everybody gets this answer right. A lot of people forget about this one, because since this is positive, you know there's going to be two solutions. You have to set up the absolute value equal to the positive and the absolute value equal to the negative. So now you can get your two solutions. So 5 minus 3 is 2. Negative 5 minus 3 is
Negative.
-8. And there are your two solutions. How do we do on that one? Okay. I'd be willing to bet everybody got this one right. And maybe there's a few of you who forgot about that one. So don't forget tomorrow to make sure you get both of them. All right, for this one, before I do my two equations, I have to,
Add 9.
because we need to isolate the absolute value first. So that gives us absolute value of x minus 11 equals 2 plus 9 is 11. Now, before you tell me the answers, how many answers should I expect to get? 2, because it's positive, right? So let's figure out our two answers. X minus 11 is equal to 11, or x minus 11 is equal to negative 11. If you write it out like that, you're going to get the right answers.
Okay, we know one of them is 0. Okay.
The people who have trouble with these are the people that try to do both of them in their head. If you try to do these totally in your head, they can get confusing. But if you write them both down, you're going to get them right. Because 11 plus 11 is 22. And negative 11 plus 11 is, and there are your two answers. Good. All right, last one. What two numbers do I got to get rid of before I even start?
So first you'll add
The net, the negative 2 and the -4.
Yeah, I got to get rid of those two numbers, because those two numbers right there are keeping this from being isolated. So now you got to remember your basic algebra solving equations stuff. Do you get rid of multiplication first or subtraction? Subtraction. You always undo addition and subtraction first, and then you undo multiplication and division later. So how do I get rid of -4? Add 4 to both sides. That gives me -2 times the absolute value of x plus 5 equals, let's see, 10 plus 4, 14. Now divide both sides by, do that,
Oh, look, it equals a negative. Not a
-2.
solution.
You heard the man.
Absolute value of x plus 5 equals -7. And this causes Henry to have a problem. Why?
There is no solution.
Because there is no solution. Can the absolute value, now, what if this said +7?
That would be two solutions.
Then you would figure out your two answers, but this one has no solution. So your assignment for tomorrow is to get a 100% on tomorrow's test. Study these.
That'd been funny if they really want that.